So today I'm pleased to welcome Scott Garberding to this conversation. Scott is an automotive industry veteran, where he most recently served as the Chief Manufacturing Officer at FCA, a position from which he retired in 2021. And before this, he was also the Chief Quality Officer at FCA. His career at Stellantis and FCA ranged for almost 30 years, and he served in senior leadership areas, roles, spanning manufacturing, purchasing, quality, among other functional areas. And we're also very lucky to have Scott on the advisory board of Viaduct. So Scott, welcome, and thank you for chatting with me today.
Thank you, Matej. Pleasure to be here talking to you.
For years, you've been on the vanguard of using connected vehicle data to improve quality in manufacturing. How did you recognize the potential of this data before it became such an industry-wide focus?
Well, starting with the manufacturing piece, it was pretty simple because in manufacturing, we have a lot of people and a lot of data, people making cars, of course, and data coming in from dealers, from the field, from warranty systems, and more recently from vehicles. But it's a challenge to take the data and get exactly the right specific problem to the right person ultimately in the manufacturing facility to make sure that we understand problems as quickly as possible and, of course, correct them as quickly as possible.
Right.
I had a boss who once told me that the trick to improving quality was to fix problems faster than you make new ones. And that sounds kind of funny, but it's actually very much the case because you have supplier changes, other product changes, other things happening that can be the source of quality problems. And you've got to make sure that you stop those at the source as quickly as possible.
If you kind of look back at your, at your career, what were some of the biggest challenges that you faced or you found others facing when it came to shifting to a more data-driven quality or manufacturing culture?
Well, although, as I mentioned, we had a lot of people, say, making cars, we had fewer people who we could assign to set priorities, understand what the key problems are, really make sure we got the right technical resources often assigned to the right problems. And understanding really the root cause of a problem based on just a warranty report, a dealer report, could sometimes be very difficult. So I found that we were hungry for information, and because any large automaker has a lot of vehicles in the field, millions, in fact, there's a huge data flow coming from those vehicles, from those dealers, et cetera. And it was really, really difficult to set priorities without the right tools. We were floating in data, but we had, I would say, very, very skilled people using very manually intensive tools, software tools, to try to set these priorities. And I spent some hours just watching them work and having them explain to me how they worked, and pretty quickly realized that we were going to overwhelm these people if we didn't have better tools.
What other big obstacles do you see that are preventing, automotive OEMs from kind of fully leveraging their data to improve their processes?
Well, there are common occurrences of, I would say one common occurrence would be problems that are due to component interactions rather than a simple component failure. And sometimes we'd find that we thought we had two problems, or we thought, and this is a different problem that goes to making an ineffective repair. We thought that, say, replacing a component would solve a problem, and then learned months later that replacing the component wasn't always an effective corrective action because of, say, an interaction in the vehicle. But if one spends several months learning this, you've produced tens of thousands of cars in the meantime while you're learning that lesson. So one of the things that I think is absolutely terrific about Viaduct's tool is it can make those links. It can often identify related situations and point a user toward the fact that there seems to be an interaction here amongst components, which is super valuable for a problem-solving team because they can take that information and look more broadly at the components and understand really what's happening. So that ability can be a huge money saver and protect customers, frankly, from issues being put into the field. And then secondarily, it's very expensive to give a prescription to dealers to say replace a component when in fact that isn't the solution for the problem. So tools like Viaduct's tool can be terrific for getting to the real root cause of a problem like that and getting it corrected quickly.
And when you look back, are there any specific examples, to the degree that you can share them, of kind of significant or memorable quality or manufacturing issues that you encountered, during your career, where kind of advanced data analytics either helped you in identifying or addressing them earlier, or if you had the kind of tools that exist now, you would have been able to address them much faster?
Well, there was a specific problem with a controller in the vehicle, which we were replacing in a fairly large volume, and it was consistent every month. A few percent of cars would fail every month. They'd go to the dealer would replace a component, seemed okay for some period of time, but the problem just continued. And when we would send these components back to the supplier to be evaluated, the supplier almost uniformly would come back and say the components were fine. So for a period of time, the chosen solution was, a daily or weekly argument between our people and the supplier's people about whether the components were in fact defective or not. And so we put a team together of a few people. The supplier contributed a few people, did some very deep data analysis, and eventually found that there was a third component and some software involved in this failure. So in fact, the supplier was to some degree right that the component it was providing was performing as the supplier expected it to perform. However, it was not performing as the whole system expected it to perform. And with that team and that data, we did eventually reach a solution and we eliminated the problem. But the problem, unfortunately, went on for several months. And we replaced a lot of components in error. We disappointed customers because we didn't understand the issue and wasted a lot of people's time. And I'm confident had we had Viaduct's tool at that time, we could have much more quickly seen what was happening, eliminated all of those problems.
Scott, maybe just if we kind of move forward and kind of look ahead, in your view, where is the industry right now in terms of maturity of adoption of data analytics and or AI when it comes to quality specifically?
Well, I think every automaker and frankly the large suppliers too,
right,
from my recent observations, have made a lot of progress along the lines of sort of business intelligence, being able to organize data maybe more quickly, focus somewhat more quickly on pulling the right data set together per se, or linking data sets from multiple systems inside the company. In my former company, we'd worked on that as well. but we were still reliant on people to, link the right data sets and look at the correct dates and make all the decisions about where we were focusing. So what we didn't really have is tools that could help us look more broadly at data sets and make associations between problems and create a definition of the vehicles that were likely affected by a specific problem. That was something else that we spent significant time on. And so, again, since it comes down to priorities and assigning the most important problems to problem solvers, although I feel like we had highly skilled people and we made big improvements, so for sure we were getting better. We were not to the point where we were seeing problems as fast as what was possible, and in as complete a sense as what was possible. Viaduct's tool can point out quickly where, say, repairs are being made multiple times, almost instantly. And that kind of data, when linked with other pieces of a problem, can be super helpful. So I would say we had good progress with organizing our data, but not necessarily intelligence that we could apply to analyzing that data to really focus us on the things that were most important.
What other, promising applications of AI or advanced analytics in the automotive space, or specifically automotive as it comes to quality and manufacturing, do you see over the next 5 to 10 years coming over the horizon that really can change things?
Well, there are two places that I think would be interesting, and of course there are many more out there, but two that I would mention today would be one on the plant floor, and then two in the arena of developing components, systems, and vehicles, new ones. Mm-hmm. So if you start with the plant floor, this is another arena where we collect a lot of data, many devices in a plant feed data that we collect and can be used for problem analysis. But we could most certainly apply more intelligence to try to understand quite specifically at a workstation level, ideally, from where problems are emanating, or potentially at the work, if the problem is with a component that's incoming, looking at where that component is added to the vehicle, or if the OEMs could work out data sharing with suppliers, understanding even more deeply where that problem may have come from. Because we talked earlier about really reactive capabilities where we're looking at warranty data, or we're looking at something after the event. And obviously automakers want to, push toward prevention, not simply identifying something quickly, but into not having the problem at all. And I think there's more intelligence that can be applied to the manufacturing sites to allow quicker identification and or prevention of problems. And then in the process of developing vehicles, the challenge companies have is they build, relative to full production, fairly small fleets of vehicles, tens, hundreds of vehicles, depending on the type of launch. And there's a lot of data taken from those vehicles. There are specific monitors put on many of them to collect data. And then there are, of course, observations from the drivers, mechanics, and other people. But this was an area where, again, I felt in my past, we could have done more to really associate a mechanics observation written in a log or entered at a computer with something that was observed on a track. Because often in that environment, you can get one occurrence of something, and then you need to decide, okay, what does this mean, right? Is this a repetitive problem? Is it a manufacturing problem with a prototype component? Is it a design problem that could make its way into mass production? Is it an interaction? What is it? And you have to treat every one of those pieces of information like gold because they're all important. But it can be difficult and frustrating to try to work one's way back to what really happened and is it something real or is it not? And I think this is an arena that's really ripe for AI type tools to take all that information in and again help identify what's signal and what's noise so we can prioritize the work.
Yeah, 100%. And we see some of that in our work with OEMs, tier ones as well. And one observation that I would share is in the pre-production setting, yes, you have maybe tens to hundreds of vehicles, but each vehicle is instrumented in a way that there's just a deluge of signals coming, on a millisecond to second basis. And it is very similar to the post-production sense that you have an overwhelming amount of data. And really the question is, how do I prioritize? In this case, maybe not as much to identify that there is a problem, but how do I root cause this problem using hundreds of sensors or maybe thousands that each vehicle is equipped with.
Absolutely correct.
Yeah, and maybe one follow-up question here is, do you see potential applications of AI and advanced analytics even higher, kind of even further back in the design process? Before we get to the point of having pre-production vehicles, when it comes to component design or vehicle design itself, is there value in using AI tools there?
Well, I would say conceptually, absolutely yes. We spent a lot of time, and our engineering team spent a lot of time trying to anticipate potential failure modes of components, of vehicle systems, and ultimately vehicles. And spent a lot of time sort of then manually working with a design, could be a product design or a process design, depending on the activity, and looking for opportunities to potentially create these issues, and then looking for countermeasures to make sure that the issues couldn't be created.
Mm-hmm.
But could we really walk that back into, say, the underlying archetypes of a design? If a particular approach is used, here are the vulnerabilities. Were we good enough to do that? So I would say some very experienced, thoughtful people were, but one can't populate an entire company with people with that sort of knowledge.
Yeah.
And so I would say off the top of my head, it wouldn't be a simple undertaking, but I would think there'd be a lot of potential there for sure.
Yeah, thank you. And this is, I think, good segue into my next question, which is, given everything that we've discussed that's kind of coming down the pike, how would you define the DNA, the operating model, the talent profile, the culture of an automotive quality organization that's going to thrive over the coming years versus one that's going to struggle?
Well, you need to launch cars with high quality, which sounds simple, but I mean, you really have to drive the activity from reactive to preventive to proactive. And there are a lot of opportunities to learn. And I had the pleasure or displeasure of sitting in a number of jobs where I got to see a lot of problems over a number of years. And so sometimes you can go to speak to a team and say, if you do this, here's what's going to happen unless you think differently about it. And I can give you these 3 examples and data to show you why. But the fact is, because of changes in people, various discontinuities, the fact that we don't have systems like we just discussed for upfront development, I'll say companies, and by the way, not just auto companies, but suppliers, right? At every
Right.
level, tier 1, tier 2, tier 3, create problems, right? And sometimes same problems, many times, frankly, the same problems that have occurred before. And I can say later in my career, I finally got to the point where there weren't too many problems that I would see that were completely new. They may have had some nuance about the root cause or about some interaction that allowed it to happen, but that's sort of the challenge. And another area I think every automaker would be interested in, and every supplier, would be software quality, because that's also a huge challenge. And there's more and more software in vehicles year to year right now. And it's an area that needs focus, because from what I saw in the past, and certainly what I read now, every automaker has had software issues, some that have delayed launches significantly and created other problems.
Right.
But I think these tools could apply well there also.
Yeah, thanks, Scott. And, I would just echo that we see in our work an increasing focus on software quality as well, right? When you look at the Pareto of problems that you see on a particular vehicle platform, the share that represents or is represented by software just keeps growing year over year over year. So, absolutely. If you were to kind of summarize, what we just discussed into maybe one lesson that you would like to impart onto quality leaders in the field today, in terms of how to more effectively leverage data and AI, what would that lesson be? What's the one thing that you would share?
This sounds super basic, but I can say over my career in the auto industry, which, as you said, was around about 30 years, I was in many situations, even some way at the beginning of my career, where we had access to data as a company early on in my career in plants, for instance, and different people took different approaches to acting upon the data that was available. Some that were helpful, and frankly, some that were not helpful. And, would go make changes, look at a report and see something and go make a change in the plant. And then the next day make another change. And pretty soon, we were trying to find out what was happening, because we couldn't make sense of the results. And then we realized people were intervening in an unhelpful way. Well, say that was 30 years ago. Fast forward to now, we have a lot more data. And it makes it even tougher to sort of convert the data to information that one can act upon.
Right.
And I think that's really the strength of Viaduct, is to sort of free a person working with a product from grinding through information to try to find something, and rather being notified of risks that are based on facts, and then working on those risks. Because if you reactive quality, if you want to be effective, it is all about finding and solving problems quickly. That is the entire game. And then working from doing that well back upstream in the process, as we discussed. But that's still another game of turning information or turning data into information, and then acting on the information. And in my recent experience, we had very skilled people, very hardworking people, but we still spent a lot of time grinding through data and trying to understand what really happened.
That's awesome. Thank you for sharing that. And Scott, thank you for this conversation. Thank you for sharing your insights, and I hope you have a good rest of your day.
Thank you, Matej. Pleasure to talk to you, and you too. Have a great day.